What is the difference between a series circuit and a parallel circuit? This is DC circuits. The physics of circuits is behind the operation of smartphones, automobiles, and all the electronic devices that help make life better. The next great invention will come from circuit designers that understand this physics. Maybe that'll be you. We have a circuit consisting of two batteries connected end to end. That means they're connected in series. The resistors are also connected in series. We can measure the voltage across the batteries and resistors using this voltage sensor. The voltage sensor reading will show on the digits display on the top one on the SparkView software. The current in the circuit is measured by this current sensor, sometimes called an ammeter. The value of the current will show on the lower digits display. As we measure the voltage and current, record the values in Table 1 of the lab. To measure the voltage, we place a lead from the sensor on each side of the circuit component, putting the plus or the red lead on the plus side and the negative lead on the negative side, the black one. First, we measure the voltage across both batteries. I'm going to hit start here. And so that top number there is measuring the voltage across both batteries, but the circuit isn't complete yet. I'm going to throw the switch, and it might change a little bit. So write down this voltage, the top number, in Table 1 for voltage across the battery. Next, we're going to measure the voltage across the 33 ohm resistor. So I just remove the leads. Here's the 33 ohm resistor. There's the positive side. There's the negative side. And notice the voltage, the top value changed. And so write that one down for the 33 ohm resistor. And then I can move it over here to the 100 ohm. And notice it changed again. And so write that value down. And now we're ready to measure the current through the entire circuit. And that is the bottom number. So the current is flowing around through both resistors. Both resistors must have the same current. If I switched the two leads, the digit display would be negative, but the value would be the same. Because the current reached a steady value after the switch was closed, it is called a direct current circuit, or DC circuit for short. For part 2, we have a different circuit. And we could just make it here, but for the sake of time, I've got it all made here. And so we still have the two batteries connected in series, but the resistors are connected side by side. That means they are connected in parallel. As we measure the voltage and current, record the values in Table 2 of the lab. First, we measure the voltage across the two batteries. And so again, let's connect the circuit. And it's similar to what we're getting. I have different batteries in here, so that might explain any small difference. You might be wondering why in this part we're not measuring the voltage across each resistor in part 1. The voltage would be the same because each battery terminal is directly connected to the end of a resistor by wires that have very little resistance. So this plus side is connected to each resistor here, and the minus side to each resistor here. Next, we're going to measure the current coming out of the battery and then the current going into the battery. So coming out of the battery, this is the plus side, so we're thinking conventional current. So the current comes out, goes through our ammeter, and then back to the resistors. And because the current can split up here, we're going to measure the current through each resistor separately so that the current could be different. So we have for part 2, voltage across the entire circuit. That's the top number that you see. The current through the entire circuit I out is the bottom number. And so we're going to reconnect that part. And to measure the current on this side, I have to have the charge flow through the ammeter. So now the bottom number, the voltage we already got, so don't write that down. We're on the third entry in table 2, current through the entire circuit, I in. So the current going back into the batteries. Now we want to measure the current going into the 33 ohm resistor. So I reconnect the circuit here, and then I got to create a opening to measure the current here. If I left this wire there, the current would not go through the current sensor. That wouldn't work. So now it's going through the current sensor and then through the 33 ohm resistor. And so write down the bottom number now. And then one last measurement for the 100 ohm. So measuring the current's a little bit more trouble than the voltage. So again, I've got a break in the circuit here, but I can connect the current sensor. Now that connects it, it flows through, and we get the current through the 100 ohm. If you recorded the voltage and current values in table 1 and table 2 as we went, then you're ready to complete this lab. Otherwise, you're ready to watch the video over again. You'll need to know Ohm's law to answer some of the questions. As you answer the questions, keep in mind whether this question is asking about the series circuit or the parallel circuit. Understanding how they are different is the main goal of the lab. After completing the lab, you should know how to predict the voltage and current at any point in a series or a parallel circuit. This is an important skill that all circuit designers need to learn. I wonder what you will do with your new skill.